Hello and welcome back to the Converging, Diverging nozzle video series. In the first part I outlined essentially the 8 characteristic flow patterns that will occur at the nozzle as the back pressure behind the nozzle is gradually reduced from the stagnation pressure in case 1 all the way down to some pressure below the matching pressure at the exit. Now in this part we will look closer into first 3 cases: no flow, subsonic flow and subsonic choke flow. So for that I have another pattern of the same case. Again we have that example 1.1.11.8 from monsoon nozzle, where A is equal 0.1 plus x squared. And here in the bottom I printed a little table outlining the actual numerical values, including one extra line on the top with x being equal to -10. In our analysis we're focusing on -5 to +5, but having some extra point outside that domain with very large radius and area, we have essentially stagnation conditions, and we're not showing it here, but there would be our condition 0. So again we have the throat in the middle, and throat doesn't have to be in the middle, of course, but this is the symmetric nozzle, so throat is the position where the diameter of the nozzle is minimal, and we have exit and some back pressure conditions. So let's now look at cases. Case 1, no flow. That's sort of trivial case just for completeness. There's not much to be said about that, rather than essentially back pressure is equal to stagnation pressure in front of the nozzle, and Mach number equals 0 everywhere. Of course, when back pressure is equal to front pressure, then the pressure ratio will be 1 everywhere as well. Let's call that condition the nozzle is sitting on our desk and nothing happens. Now we have case 2, which is subsonic flow. And let me immediately write here case 3, which is subsonic choked. Often in cases with nozzle it's easier to deal with some limiting cases, so here we'll say it's unique. In other words, there's only one line that pertains to that condition. Choked means essentially that Mach number at the throat reached 1, and it is this. In this table I have exit Mach number, saying exit Mach number is less than 1, but this is essentially at the throat. In these limiting cases Mach number reaches 1, and initial Mach number is 0.17. So I have sort of a dotted line for cheating here, so I can make a nice round. And then what happens with pressure? In that subsonic choke case, when Mach reaches 1, pressure reaches essentially, so this is pressure OP naught, this is Mach number. So pressure reaches the value of 0.528. That's of course in this particular case where K equals 1.4, the atomic gas that air belongs to. So when pressure at the throat reaches the critical value, so we'll call this P over P star, then the path, the pressure drop ahead of the nozzle follows this critical curve. There's only a single curve that for a particular distribution of areas that will get you to the critical pressure, but because back pressure is still very high, then it will go back and reach some value. You can see here that value for this is subsonic pressure. So on the left, minus 0.5, it's 0.980, and this is the symmetric case because the nozzle is symmetric too and subsonic, and it reaches basically 0.98 ratio, and at the back is 0.98 is again, and Mach number is going back down to the same value of 0.17. So this is 0.17. So how do we know that it is exactly 0.17? Well, for the choked flow, we have a condition that area ratio of exit area over throat area is really equal exit area over critical area. In other words, we will label the throat area to be the critical area only if the Mach number here reaches 1.